Alright, so we're going to be going over all of the lessons for Module 2 in this video. So Module 2 has 6 different lessons working with linear functions. So the notes that are attached have all 6 of these PDFs put together. So it's essentially one document, but everything will be there in that one document. So I'm just going to highlight some of the stuff that is important on these notes, and then I'm going to do a couple of examples, stuff that you need to look out for the test. So 2.1 is working with linear functions written in function notation. So function notation, we have f of x equals ax plus b. Let me get my highlighter pink. So something that is important is if a does not equal 0, then the domain and range of f are both going to be negative infinity to infinity. So this is something that is important. It says right below that this is known as slope-intercept form, y equals ax plus b, where a is the slope and b is the y-intercept. So this is also something that can be important. I'm going to put this in yellow. A is the slope and b is the y-intercept, and then we have 0b. Okay, there it goes. Alright, so graphs are vertical, horizontal, or oblique lines, and it takes 2 ordered pairs to graph the lines. When graphing a line, it's best to use the intercepts, which is where the line crosses the x and y axis. So the x-intercept is when we set y equals 0 and solve for x, and then the y-intercept is when we set x equals 0 and solve for y. So that is something that is important. I'm going to highlight this, because this is what you're going to do working some of these problems. So we have a couple examples. If you just want to look over these, we have that f of x equals 2x plus 8. When we set y equals 0, we can find where our x-intercept is. And when we set x equals 0, we can find our y-intercept. So we can see on the graph exactly where this line goes across our intercepts. In the function f of x equals ax plus b, if a equals 0, then it says that the domain and the range are both negative infinity to infinity. And then we have an example here, just what it looks like whenever we have the horizontal and the vertical lines. So these are the notes that you should look at. I am going to do a couple of exercises at the end of 2.2. So 2.2 just kind of extends on 2.1, but we are looking at the linear equation in standard form, which is going to be this ax plus by equals c. So whenever you get it in standard form, the best way to graph these type of things is to create a table. We want to find our x and y intercept, so we're going to set y equals 0 and x equals 0, and we can find where they intercept on those lines. Alright, so number 1 on 2.1 homework, it says to graph the following linear function, give the domain and range, and identify whether it is a constant function. And we have that f of x equals x plus 8. So f of x, this is 2.1, check for understanding. F of x equals x plus 8. The way that I like to tell people to do these is with a table. So we have our x and our y, and we are going to just try to figure out where this line is going. So if we set x equal 0, so we have f of 0, then we have 0 plus 8. So wherever our x is, we are going to put that 0 And so we get that f of 0 equals 8. So that means where x equals 0, then y equals 8. Okay? And then we can find some other places. Let's set y equal to 0 so we can find our x-intercept. So if 0 equals x plus 8, we can subtract 8 from both sides, and we get that x equals negative 8. So we have our intercepts. Let me do one more. Let me do x equals 1. So if we have f of 1, this equals 1 plus 8. So where x equals 1, then y equals 9. So we have some points. Let's go ahead and try to graph this. All right. And honestly, like, you don't have to do this. I'm more of a visual person. I'm going to put this down here because y is positive, and so that means that we're going to be going up this line. So this is our x, this is our y. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 10. All right, and then we've got 8. So we have where x equals 0, then y equals 8. So x is 0, we're going to go up to 8. Let me use a different color. Okay. And let's go ahead and do 1, 9. So x equals 1, we're going to go over 1, and then we're going to go up to 9. Okay. And then where x equals 0, where y equals 0, then x is negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. This is going to be negative 8. So this is where the line crosses over here. So we are going to connect these lines, and this is what our line is going to look like. Now, you don't have to draw the graph, like I said, unless you're just one of those type of people that you're visual and it helps you to see it. So we are going to graph this on to this right here. So I'm going to click to enlarge it, and we are going to have a line. So I'm going to start with our negative 8, 0. So we've got, and you can zoom in. I know this is zoomed out, but you can see in that yellow highlighted up top that we have negative 8, 0. So that's going to be our first point that we do, and then the other one is going to be 0, 8. So that's where we cross the y-intercept. So 0, 8, okay, and I'm going to click, and then I'm going to save. And so this is our line. Well done. So you will have a question like this on your test. So after you graph it, then it's going to ask you for the domain and the range. So we're going to select A. The domain in interval notation is, and remember our rule from the very beginning of the notes that if A does not equal 0, then your domain and your range is going to be negative infinity to positive infinity. So it's going to look like this. And I'm actually just going to highlight this and copy it. So that way I can just copy and paste it. Alright, so that's going to be our domain. Alright, and then our range in interval notation, so this one is B, and it's going to be the same thing, negative infinity to infinity. Okay. All right. So is f of x equals equals x plus 8 a constant function? The last part says, is f of x equals x plus 8 a constant function? So let me go back to our notes. I don't know if I touched on that, but it says in the function f of x equals ax plus b, if a equals 0, the definition of a linear function in the definition of a linear function, then the equation becomes f of x equals b. In this case, the domain is going to be negative infinity to infinity, and then the range is just going to be b. And then it says a function of the form f of x equals b is a constant function. So what makes it a constant function is whenever a equals 0. So in this particular question, our a is going to be 1. So it's not 0. So that means that this is not a constant function. Okay. Question number 2. I'm going to do this one as well. So that says graph the linear function f of x equals 1 over 3 times x minus 4. Okay, so number 2. X equals 1/3 x minus 5. So f of x equals 1/3 x minus 5. So we're going to do that same thing. We are going to create a table, and I'm going to find where x equals 0 and where y equals 0. So let's do x equals 0 first. So f of 0 equals 1/3 times 0 minus 5. So 1/3 times 0 is just going to be 0, and then 0 minus 5 is negative 5. So where x equals 0, then y equals negative 5. And then we're going to set y equal to 0. So 0 equals 1/3 x minus 5. So remember, when we're solving for x, we need to get x by itself. So I'm going to move our 5 over to the other side. Whatever we do to this side, we have to do to the other side. So we get 5 equals 1/3 x. And we want to get rid of our fraction now. To get rid of this fraction, we're just going to multiply it by its denominator, because what happens is that these 3's will cancel out and we are left with a 1. And we have to do the same thing to the other side. So we multiply by 3 and we get 15 equals x. Now, if you're confused about how these cancel out, look at it this way. If we have 1/3 times 3, how do you multiply fractions? You multiply fractions straight across. So we have to multiply 1 times 3 and then 3 times the fraction over here. So since we don't have a fraction, we can create one by putting 3 over 1, because 3 divided by 1 is just itself. So it's the same thing. So 1 times 3 gives us 3, and then 3 times 1 is 3, and whenever we divide 3 divided by 3, we just get 1. So this is what we can do to cancel out fractions. Just remember, you multiply it by its denominator. All right, so I'm not going to draw the graph like I did up there. I'm just going to come over here and I'm going to add our line. So we want this to go down to 0, 5, and then our y is going to be, where y equals 0, then x equals 15. So we've got 15, 0. Okay. All right, and let me put 15 over here. Okay. So is the function a constant function? Remember our rule from the notes. Whenever a equals 0, then it is a constant function. In this case, a does not equal 0, so no, it is not a constant function. And then for the domain and range, it's just going to be the negative infinity to infinity, because same thing, a does not equal 0. Alright, and I'm just copying, I copied that and now I'm just pasting it. Alright, So I'm going to skip over that one and let me go to our homework for 2.2. All right, so 2.2 homework is also super short and it's only 4 questions. So question 1, question 2. Let me look at number 2 because it's a little bit harder than number 1. And it says, graph the line negative 5y minus 2x equals 0. All right, and it says give the domain and range. So we're going to graph it and we're going to give the domain and the range. So let me get like purple or something. So this is 2.2, check for understanding, and this is number 2. And we've got negative 5y minus 2x equals 0. So basically what we're going to be doing is kind of the same thing with our x and our y. We're going to set x equal to 0 and then set y equal to 0. So let's start off by setting x equal to 0 and see what happens. So we've got negative 5y minus 2 times 0 equals 0. Okay, so negative 2 times 0 is just 0, and we're left with negative 5y equals 0. Okay, and whenever we're solving for y, we can divide both sides by negative 5 to cancel this out over here, and we are left with y equals 0. So it looks like our both where x equals 0, y equals 0. So what that means is that they both intersect in the middle. So we're going to have to just kind of make up some points to figure out where this line is going. So let's just do, let's just start with x equals 1 and go from there. So negative 5y minus 2 times 1 equals 0. So negative 2 times 1 is negative 2. And we still have negative 5y and then equals 0. Now I'm going to move 2 over. So we're going to add 2 to both sides. And we get negative 5y equals 2. And we can divide both sides by 5 to get y by itself. And we get that y equals negative 2 over 5. So our negative symbol from 5 is just going to be in the middle. So negative 2/5 is going to be this point. So that's going to be kind of hard to graph. So what we need to do is figure out a number that we can put in for x to get a whole number for y. So since we have 5, so let's try to use where x equals 5. So we have negative 5y minus 2 times 5 equals 0. Okay, so negative 2 times 5 gives us negative 10. And we want to get rid of our 10 first. So we're going to add 10 to both sides. These cancel out and we're left with negative 5y equals 10. We are going to divide both sides by negative 5. This side will cancel out over here and we're left with y equals, and then 10 divided by negative 5 is going to be negative 2. So where x equals 5, y equals negative 2. So 1, 2, 3, 4, 5, and then it's going down for the negative. So our graph is going to look like this. Okay. So I've got 0, 0, and then I've got negative, I got 5, negative 2. So we can see we've got 5, negative 2, and then it also goes in the middle. 0, 0. I'm going to save it. All right. The domain and range is negative infinity to infinity. Paste, enter. All right, next question. Number 3. So it says graph the line x equals 1. Okay, so this is, I'm going to do red. Number 3, and it says to graph the line x equals -1 and give the domain and range. So where x equals -1, I know that we looked at it in the notes and it is a vertical line, but if we were to actually find points on like using our table, all of the x's are going to be -1 is what this is saying. But what changes is where y is. So y can be 1, 2, 3. So if we were to graph this, x stays on -1. So it would look like this. X is going to be -1. So our line is going up and down, vertical. So I'm going to graph it first. And so we've got select my line. We've got -1, 1. So we've got it going up and down. All right. Okay. Now, what is going to change is our domain and range because our A equals 0. So whenever A equals 0, our domain and our range is not going to be -infinity to infinity. Now, our range, it is -infinity to infinity because it is going on up and down. It's going on into infinity and then -infinity. So remember, range is with our y. For our domain, we are only looking where x equals -1. So we're going to use the brackets. So it's only at -1. So our domain, we're going to use our brackets. You can find that on your keyboard. Or I'm sure if you click more, the brackets are in here somewhere. Actually, where are the brackets? Oh, gotcha. So we're not going to select the domain as an interval. We're selecting this one, and then we're just going to do -1. No wonder they don't have the brackets. All right, and then the range is going to be -infinity to infinity, and that's all you're going to be doing on this question. Number 4 is similar to number 3. It just gets has another extra step. All right, so continuing on with the lessons, we're going to be looking at 2.3, and it says to calculate the slope of a line. So finding the slope, we are going to use where m equals the rise over the run. So I am going to highlight this. M equals rise over run. And we can find it if we have two different points, x1 and y1, and then x2 and y2. We can take those points and we can subtract y2 minus y1 and x2 minus x1 to find our rise over run. So there's some examples on our notes that you can look at. They give you examples with points, and then you're going to find your slope. If the denominator is 0, the slope is undefined. So where it's 0, slope is undefined. So the slope of a vertical line is undefined. So that's whenever you have a vertical line. Whenever the slope equals 0, that is a horizontal line. And then there's some graphs down here. We have a positive slope, negative. We have the slope equals 0, and then an undefined slope. And then another thing on 2.3 is going to be the rate of change. So it says, remember, m equals a change in y or a change in x. And then we have an example that talks about the rate of change. It's a word problem. It says in 1980, the number of high school dropouts in a country was 5,217,000. By 2009, the number had decreased. Find and interpret the average rate of change per year. So all you're going to be doing is just basically finding that slope. So the average rate of change, so we take our points, we have the years 1980 and 2009, those are going to be for X, and then we have the values for each of those years, so we'll put that for Y. And then we're just going to use our formula up here where we take Y2 minus Y1 and X2 minus X1, and we're going to subtract those out and then divide, and we get that the average rate of change is this negative 72.3 thousand each year. Let me go ahead and look at 2.4. So a little bit deeper into the slope with standard form. So if you have standard form, your slope is going to be that m equals negative a divided by b, and the y-intercept is going to be 0, c over b. Whenever you have slope-intercept form, y equals mx plus b, m is the slope and the y-intercept is 0b. And then we have a vertical line and then the horizontal line. So we did just talk about these. And then in these examples, you're going to graph using slope-intercept form. And on your homework, you're going to graph. And you're also going to figure out if it's a function, find the domain and range. And that is basically it on that homework. So let's look at the homework for 2.3 and 2.4. So 2.3. Looks like this. It is 5 questions. All right, so check for understanding 2.3 looks like this. You got 5 questions. So let's look at question number 1. It says, find the slope of the line containing the pair of points -5, -9, and then 8, 5. So finding our slope, let me get our blank sheet. Let me make this smaller. Okay. So we've got 2.3, the check for understanding, and we're going to be looking at number 1, and we're going to find the slope. And we've got the points -5, -9, and 8, 5. Okay, so finding our slope, m equals, so we are going to take y2 minus y1 divided by x2 minus x1. So basically we've got x1 and y1, x2 and y2. So y2 is 5 minus -9. I'm putting that in parentheses because we have a double negative. And then x2, we've got 8 minus, and then same thing, -5. So anytime we have a double negative, they cancel out and it becomes positive. So 5 plus 9 is 14, and 8 plus 5 is 13. So our slope is 14 over 13. So you can do this a couple ways. You can click this right here and it'll give you a fraction, or you can actually just type in 1/4, and then if you hit your slash, your division symbol, it creates the fraction for you. So 14 over 13, that's all we're doing on that question is finding the slope. Number 2, same thing. What is the slope of the line? You're going to be working that the same way. You have x1, y1, x2, y2. Okay. Same thing on this one. So you will have a test question that looks like one of these questions. Average rate of change. So that is just finding the slope. They give you the points on there. And then just like that other question, there are 4 questions. So number 1, number 2, I'm going to look at number 2 because this is what the test question looks like. And it says to find the slope of the line and sketch the graph, we have 3y equals negative 4x. Okay. So what we're going to do is we want to get y by itself. Uh-oh, why is it zooming? Okay, let me just do this. Okay. All right, so this is going to be 2.4, check for understanding, and this is number 2. And it says find the slope and sketch the graphs. So we have 3y equals negative 4x. Now, one thing about these is make sure you write these down correctly. There have been times where even I myself write the wrong thing down, and even though I calculate it correctly, it's not going to be right because I didn't write the thing down correctly. So 3y equals negative 4x. Find the slope. So we're going to get y by itself. We want to put it into the form y equals mx plus b. We're going to do it in slope-intercept form. So to get y by itself, we're going to divide both sides by 3. Oh, not negative 3. We're going to divide both sides by positive 3. So these cancel out on this side, and we're left with y equals negative 4x divided by 3. And what that is just basically negative 4 over 3 times x. So I'm going to put x off to the side. So this is in our form y equals mx plus b. So in this case, m equals negative 4 over 3. So m equals negative 4 over 3. And then in order to graph, let's just create our table. I am going to set, if I set x equal to 0, then y equals 0 as well. So if we have y equals negative 4 over 3 times 0, then that times that is 0, so y equals 0. So that's just going to be 0, 0. Let's set x equal to 3. Since we have a fraction and our denominator is 3, let's set it equal to 3 so that they can cancel out. So y equals negative 4 over 3 times 3. Those cancel out, and we're left with y equals negative 4. Okay, so we have a couple points that we can use to graph our line. So part A is the slope, and our slope is going to be -4 over 3. Uh-oh, not 0.3, just 3. All right, and now we want to graph. So we have our line tool, and we're going to start with 0, 0, and then we're going to also graph where x equals 3 and y equals -4. So we're going to go over to 3 and then go down to, uh-oh, I didn't mean to click, -4. So 3, -4. Okay, so save, and we'll check, and then we're good. So I think that there is a question like this. And then also I think there's one like this. So it says graph the line passing through the given point and having the indicated slope. So in this case, they actually tell us that the line is going through this point and that we know our slope is -1 over 4. So if I was to, so this is number 3, we have line passing through, I'm sorry, not negative, it's just +1 and -2. And the slope equals -1/4. All right, so what we're going to do is we are going to go to our graph, and we are going to graph this point 1, -2. So 1, and then -2 is right here, and then it says our slope equals -1 over 4. So I'm going to put our negative with the 1. And remember, our slope is going to be rise over run. So the number that's in our denominator is going to be rise. So that means that that is going either up or down. So for -1, we're going to go from here and we're going to go down 1, and then we're going to go over 4 because 4 is our run. That's going to be going either left or right. So 1, 2, 3, 4. Our point is right here. And that is going to be +5 and -3. Now, if we were to have the negative with the 4, we would have a +1 and then a -4. So we could go up 1 and then 1, 2, 3, 4. It would go right here. So this would be a -4. So this is what our line is going to look like. That's not good. Dang it. So it's going to be right here. Through this. But we have a couple points that we can use. We can use where x equals 5 and y equals -3. So I'm going to get our graph and get our tool going, and we're going to start with the point that they give us, which is +1 for x and then -2 for y. So I'm going to click there, and then I'm going to go over, and we've got +5 and then -3. Bam. All right, save it, and we should be good to go. All right. All right, the last two lessons for Module 2, we've got 2.5 and then 2.6. So 2.5, looking at equations of lines and like linear models. So this first part is just like a review. It talks about the different graphs and the slopes, and it talks about standard form that we looked at, and then slope intercept form. We have the vertical line, horizontal line. So this is kind of just repeated from what our notes said earlier. What is new is going to be the point slope form. So point slope form, we've got y minus y1 equals m times, and then in our parentheses we've got x minus x1. And it says m is the slope and x1, y1 is a point on the graph. So if we know a point on our graph and we know our slope, we're going to use this point slope form instead of what we did on that previous example. So there's some examples here. They give you a point, they give you the slope, and you're going to be graphing for that. So there's more examples down here. And this is kind of what we just went over in that previous example on our homework for 2.4. But we're just using our new point slope form. In 2.6, working with perpendicular and parallel lines, it says parallel lines, we've got two distinct non-vertical lines are parallel if and only if they have the same slope. So if they have the same slope, they are parallel. Perpendicular lines, it says two lines, neither of which is vertical, are perpendicular if and only if the multiplications of their slopes has a product of -1. Okay. And then it says also a vertical line is perpendicular to any horizontal, and a horizontal line is perpendicular to any vertical line. Okay. And then we've got some examples. It says write an equation for a line parallel to, and then they give us a line and then passing through the point, and then it says parallel lines have the same slope. So first you have to find the slope, and then you'll use point slope formula, and we come up with another line. And then here's another example for that. So let's look at our homework for first 2.5, and then we'll do 2.6. So 2.5. So 2.5 is longer. We have 13 questions that we will be looking at for 2.5. I'm only going to go over the ones that you will need for the test. So let's look at number 1 on here. Let me come back to our blank sheet. So this is 2.5, check for understanding, and we've got number 1, and it says write an equation for the line described, and it says give the answer in standard form. So back over here, I'm going to say standard form. Remember, our standard form is where we have like ax plus by equals something. So it tells us that we are going through the point 4, 9, and our slope m equals -4. So we're going to use that formula that they gave us in 2.5, where y minus y1 equals m times x minus x1. So let me write that really quick. Okay, so in this case, we are going to use for y1 and x1, it's going to be this point that they gave us. So y minus, let me do this so we can see like y1 and then x1. Alright, so y minus 9 equals, and then we have that m equals -4, so -4 times x minus 4. So we're just plugging everything in for the pieces that we have. Let me do this. for m. All right. And now we can work through our problem and solve it. So we get, the first thing that we're going to do is distribute our -4. So we've got -4 times x is going to be -4x. And then -4 times -4 gives us a positive 16. And we still have y minus 9 over here, but I'm going to get rid of our 9 and bring it over. So we get y equals -4x, and then we've got 16 plus 9 gives us 25. So we've got y equals -4x plus 25. But we want it in standard form. So if we look up here, our standard form is going to be ax plus by equals c. So I need to get our x over here. So I'm going to add to get rid of it over here, and then we'll add it to this side. So we get 4x plus y equals 25. Okay, so 4x plus y equals 25. All right, great job. Next question. So the slope is undefined on here. Similar to number 1. So we'll look at number 4. It says write an equation of the line passing through these points and give the answer in standard form. So this is kind of like what we did on number 1, but they don't give us the slope. We have to go and find it. So let me change to like a blue. Number 4, we've got the points -1, 4, and 3, 5. So the first step that we're going to do is find our slope. So m equals, remember, we've got y2 minus y1 divided by x2 minus x1. So x1, y1, x2, y2. So we'll take 5 minus 4 divided by 3 minus -1. So 5 minus 4 is 1, and then our negatives cancel out. 3 plus 1 is 4. So m equals 1 over 4. Now we can, we're just going to take one of these points. We don't need both of them. And we can find our line. So let's choose our first point, -1, 4. So we've got y minus y1, which is 4, equals m times x minus x2, which is, x1, which is -1. Okay, so these are going to cancel out. We get x plus 1. And we did find our m, so I need to change m to 1/4. Okay. So we've got y minus 4 equals, and we're going to distribute this. So we've got 1/4 x plus 1/4. Okay, and now I'm going to add 4 to get y by itself. So we've got y equals 1/4 x, and then we're going to add 4 to 1/4. So 4 and 1/4. If I want it as a fraction, 4 times 4 is 16 plus 1 equals 17 over 4. Okay, so plus 17 over 4. And to get x, we want to get x on the other side. All right, we want to get x on the other side, so I'm going to subtract 1/4 x, those cancel out, and then we've got negative 1/4 x. So remember, the x comes first, so we've got negative 1/4 x plus y equals 17 over 4. Okay, so even though that answer is correct, we have to get rid of our fraction and also get rid of our negative right here. So to get rid of our fraction, I'm going to multiply everything by 4 because 4 is in our denominator. We want to cancel that out. Actually, I'm going to do negative 4. We want to cancel that out. So we're going to multiply everything by negative 4. That means all 3 of these pieces need to be multiplied by negative 4. So we've got negative 4 times negative 1/4 x, and then we've got negative 4 times y, so that turns into negative 4y, and then we've got negative 4 times 17 over 4. So remember, we can cancel our 4's out, okay? And we have a double negative, so these become positive. So remember, we want our x has to be positive. So we end up with a positive x minus 4y equals negative 17. So I've got x minus 4y equals negative 17. All right, great job. Okay, so this one is similar to that one. These are just extra practice. I am going to look at number 9. It says, find the slope and y-intercept of the line with the equation 4x minus y equals 5, then graph the line. All right, so this is number 9. All right, let's do 3. So I've got number 9, and then I have 4x minus y equals 5. And we want to find the slope and the y-intercept, and then we want to graph. So I'm going to set this I'm going to put it in the form y equals mx plus b. So we want to get y by itself. So I'm going to add it so that we have a positive y and get it over here. And I get 4x equals 5 plus y. And I'm going to subtract the 5 and move it over here. And we get 4x minus 5 equals y, which is y equals 4x minus 5. Okay, so we have that m equals 4, so this is going to be our slope. And then for our y-intercept, we just set x equal to 0. So we get y equals 4 times 0 minus 5, so y equals negative 5. So we're going to put our slope in. Our slope is 4. And then the y-intercept, it says type in ordered pairs. So we are going to do 0, negative 5. All right, and then we're going to graph. So I'm going to start with the point 0 and then negative 5. And then we know that our slope is 4. So Since m equals 4, we can do 4 over 1. That's the same thing. So if we go up 4, 1, 2, 3, 4, we can go over 1. Okay, so that's how we would graph that. If you want to make a table and do that, you can do that as well. All right, that's similar. Let's look at number 13. It says the graph of a linear function f is shown. Identify the slope, the y-intercept, and the x-intercept, and then write the equation that defines f. All right, so if we look at our graph, and we can actually do this and zoom out, and we can see that the line passes through where x equals 6. So we can see that so this is number 13. And we have a graph, and it's going like this. And this is number 6. And then up here, it looks like it is at 200. So our x-intercept is 6. The y-intercept is 200. And so we've got the points 6, 0, and then 0, 200. So we can use those points to find our slope. Okay, so if I have m equals, I'm going to do 200 minus 0 divided by 0 minus 6. So I've got 200 over negative 6, and we are going to simplify this. 2 goes into both of these, and I'm going to put the negative in the front. 100 over 3. So if I was to write this, it would be y equals negative 100 over 3 x plus 200. All right, so let's put everything in. Our slope is going to be negative 100 over 3. All right. The y-intercept is 200. Oh, it needs to be in a pair. So we are going to do the point 0, 200. Alrighty. The x-intercept as a point is 6, 0. All right, and then for our equation, we have negative 100 over 3x plus 200. All right, and that's everything for this question. All right, let's look at 2.6. So 2.6 is over the parallel and perpendicular lines. So there is one question that is on the test, and I believe it's like this question right here. So number 1, it says, write an equation in slope-intercept form and in standard form for the line passing through negative 1, 5 and parallel to x plus 3y equals 5. All right, so I guess we'll go back to like red or something. So this is going to be 2.6, check for understanding. And we want slope-intercept form, standard form, and then we've got the point negative 1, 5. And then, okay, so passing through -1, 5, and then parallel to x plus 3y equals 5. All right. So we have this line that they give to us. So we are going to use this. Since it is parallel, we know that our slope is going to be the same. So I'm going to put this into the form y equals mx plus b. So I'm going to subtract x. And I got 3y equals 5 minus x. I'm sorry, let me rewrite this because we want x coming first. So negative x plus 5. And then divide by 3, we got y equals, because these cancel out, negative 1/3 x plus 5/3. So our slope is going to be m equals negative 1/3. So we know what our slope is. We just need to find another line that has the same slope that is passing through this point, -1, 5. So I'm going to use where we have y minus y1 equals m times x minus x1. So I have y minus, and I'm going to use that point that they gave us, -1, 5. So 5 equals, and then we've got -1/3 times x minus -1. All right, these will be positive. So I've got y minus 5 equals, and I'm going to distribute this. So I've got -1/3 x and then -1/3. And then I can add 5 to bring it over here and get y by itself. So y equals, and then I have to add 5 over here. So 1/3 plus 5, and this is a negative. So it's actually going to be 5 minus 1/3. So if I set this up as a fraction, I'm going to set our denominators equal. 1/3 is going to stay the same. 1 goes into 3. 3 times 5 is 15. So this is how we would set this up. 15 minus 1 is 14, and then our denominator stays the same. So we get that y equals -1/3 x, and then this is a positive, so plus 14/3. So this is our slope-intercept form. So this is going to be our answer for part A. For part B, our standard, we just need to switch some stuff around. And remember, our standard form, we cannot have any fractions. So let's move x over. We actually boxed this in, so we know that's our answer. So we're going to move our 1/3 over, our 1/3 x over, and we get y plus 1/3 x equals, let me just move all this down. Okay, so y plus 1/3 x equals 14/3. And remember, x actually needs to come first. So we've got 1/3 x plus y equals 14/3. And we want to get rid of our fractions, so we're going to multiply everything by 3. So 1/3 times 3, the 3's are going to cancel out here, and we are left with x plus 3y, because remember, every single thing equals, and then the 3's cancel at the end, so we get this. So this is our standard form. So let's start with part A, the slope-intercept form. Y equals negative 1/3 x plus 14 over 3. Okay, and then for our standard form, we have x plus 3y equals 14. All right, so that is how you're going to do that one. They're also going to give you one that says it's perpendicular. Now, I'm not sure which one is on the test, but it's going to be one of these. So let me do number 2 so we can look at something that's perpendicular. So it says we're going through the point 1, 7, and we are perpendicular to the line 2x plus 7y equals 1. Okay, so if it's perpendicular, so first I'm going to take our line 2x plus 7y equals 1, and I want to get it in the form y equals mx plus b. So I'm going to subtract 2x from both sides, and I get 7y equals negative 2x plus 1. And then I'll divide by 7 to both sides, and I get that y equals negative 2 over 7x plus 1 over 7. So this line that we're looking at, the slope equals negative 2/7. So we know that the line that we're looking at is perpendicular to this slope, negative 2/7. So in order to do that, so our notes say for perpendicular lines, the multiplication of their slopes have a product of negative 1. So it says on the perpendicular lines that, let me make this big real quick. They're perpendicular if and only if the multiplication of their slopes have a product of 1. Thus, the slopes of perpendicular lines are negative reciprocals. So this is something that is important. What that means is that this slope, negative 2/7, let's just put our negative in the top, so negative 2 over 7. The line that is perpendicular to this slope has a slope that is a reciprocal, a negative reciprocal. So that means that this negative is going to go away, and we're going to switch. So we're going to put 7 over 2. And since we started out with the negative, we have to drop it off because we're going to basically, like, 2 negatives cancel out. So if this was positive, it would become negative. Since it's already negative, it's becoming positive. So the slope that we're going to be using for our perpendicular line is 7 over 2. So let me just bring it down here. M equals 7 over 2. And it's passing through the line 1, 7. So, it's passing through the point 1, 7. So now we can use our y minus y1. So I'm going to do y minus 7 equals m. So 7 over 2 times x minus x1, which is 1. Okay. I'm going to distribute to both of those. I get y minus 7 equals 7 over 2 times x minus 7 over 2. I'm going to add 7 to get y by itself. And I get y equals 7 over 2x. And then, so I've got negative 7 over 2 plus 7. I'm just going to put this over 1 because we are adding and subtracting fractions. So negative 7 over 2 stays the same. I need to get this denominator to match my other one. So 1 goes into 2. 2 times 7 is 14. And so I've got negative 7 and then positive 14, which leaves me with a positive 7 over 2. So I get y equals 7 over 2 x plus 7 over 2. So let me change this. All right, and then that is the slope-intercept. Let's put it in standard form. So I'm going to move our x over. Actually, I'm going to move our y because remember x has to be positive. So I'm going to subtract y, and then I'm also going to subtract this fraction to move it over here. So I get negative 7 over 2 over here, and then we have 7 over 2x minus y. All right, and then remember we can't have the fractions, so which this actually just is 7 over 2x minus y equals negative 7 over 2. All right, so to get rid of our fractions, we're going to multiply everything by 2. So 2 times 7 over 2x minus 2y, because remember it goes to all three pieces, and then equals 2 times negative 7 over 2. Make sure you're bringing your negatives with you. That is a big mistake that people make, even I make. 7x minus 2y equals negative 7. Let's see if that is right. 7x minus 2y equals negative 7. All right. So that is it for those.